What's good, guys? Welcome to Mrs. Like 7th period. This is 3.4 part 2. Shout out to everyone. Charlotte made me say it, so here we go.
That was quite
Good
fancy.
job, guys.
Thank you. All right, so we have our notebooks open. We're going to review what we started on Friday and then continue. I will not get to the very last example of this lesson, but that's okay because the ones that are like it are on your homework. There are two that are just like it on your homework, and I go through every step to solve it, and they're not hard. You know, usually like the last examples are the hardest. This time they're not hard, so just watch that homework video and you will get all the information you need. Okay, so let's go over what type of functions we have been talking about. That's your cue to say something.
Reflection.
Thank you, absolute value functions. What do absolute value functions look like? Do they just look like a line?
No, they can look like this.
Yeah, they can look like a V. Thank you for doing that because I've been trying to go like that and it's really hard to do, and that's a much better way to show absolute value functions. It's just a V, and sometimes the V can be upside down, right? So, on Friday, we talked a lot about this very basic absolute value function, which is simply taking your input and absolute valuing it. Now, to absolute value something, is that really a verb? I don't know, and I don't really care because it helps me understand the function. So this input, which is our x value, is being, is the screen still okay?
Yeah.
Okay. Is being absolute valued, and then it gets put out of the machine, and we have our y value, or our output value. Remember, we can easily simply make a chart to show our inputs. What numbers do we have to use for our inputs?
Positive, negative.
Very good. It was kind of a trick question, but I actually really like your answer. I was gonna say technically it can be whatever you want. We don't have to use anything, but he is right. You want to use positives and negatives. And I also like to use
All real numbers.
well, I can't use all real numbers.
Non-decimals.
I would die before I finished my chart if I tried to use all the real numbers in the entire world. Are you trying to kill me, Vincent? That's not nice.
Come on,
it's
Vincent.
a famous like, well, I'm trying to do it with all real numbers and see what happens. Okay?
All real numbers.
The class would end never, and we'd all die. So you're correct. We also want to use 0. Technically, what my question was, what do we have to use? We don't have to use anything. We can use whatever we want, but there are some good numbers to use to help make that perfect little V. Yeah. What? Yes, we're definitely going to use integers because I would definitely not want to put in decimals or fractions at this point. So, I'm going to keep it really simple because all I'm going to do is go over the inputs that we can use for this. I'm just going to go as simple as -1, 0, and 1. And then for my y column, I'm not going to call it y. I'm going to call it a function of x. Good, f of x. And I can even write the entire function equals the absolute value of x, because when I do that, and then I set it, and then I solve it, then I get my output value, okay? So this would be the absolute value of -1 is?
1.
Good. Absolute value of 0 is?
0.
0. Absolute value of 1 is? 1. Let's just check to make sure we're on the right track. We've got, so these are our coordinate pairs. -1, 1. -1, 1. 0, 0. And then 1, 1. And we can see that we are right on the money. We have our chart, we have our absolute value function, and everything is good. Then it says the graph of function h, which is this guy, is a reflection of the graph over the x, it's the graph of function x, but it's a reflection over the x-axis. then it asks you a ton of very confusing questions, which we will go over in just a second. Let's first look at this new function that is a perfect little reflection over the x-axis. Let's go ahead and make a little chart to double check that those values are correct, because you never know with this thing, right? Let's see, x, and then we'll do, what should I write for my y? H of x, very good, because we're talking about this guy over here, so we'll write h of x equals -1 times the absolute value of x. So let's just use the same inputs that we were doing, and we'll use -1, 0, and 1. If you wanted to get really fancy, you could do -2, -3, and do some positives, but really we're just kind of double checking here. Okay, so I have -1 times the absolute value of -1, we have -1 times the absolute value of 0, and then we have -1 times the absolute value of 1. So let's solve these. -1, absolute value it, and you get 1. Good. Then multiply it times the -1, and you get
-1.
-1. 0. What's the absolute value of 0?
0.
When you multiply 0 times anything, you get 0. 1. What's the absolute value of 1?
This has been hard. 1.
1. And then you multiply times the -1, and you get
Negative.
-1. So here are our coordinate pairs. Let's double check.
It just makes everything negative.
It makes all of your outputs except for 0 negative.
That's
Yep.
what I meant.
Oh, well, all positive.
So basically this -1 is like, ha, ha, ha. You think you're so cool, absolute valuing everything. You're trying to be so positive. Making everything positive. You're making positive number positive, you're making negative numbers positive. Everything's gonna be so positive. Well, I'm gonna come along and I'm gonna be on the outside of the absolute value. I'm on the outside of the absolute value. You can't absolute value me. I'm gonna turn everything negative. And the zero's like, yeah, you just try.
You can't do that.
You like that performance?
Encore!
Okay.
Encore!
You sound like you should be in South Park.
Huh?
That was a very interesting observation. I don't know if I should take that as a compliment.
What's up, Bart?
Okay, what's that from?
So basically 0, since it has a big hole at 8-1.
Sometimes what?
Because it has a big hole, basically it's 8-1.
8?
At 8-1.
It's 8, 1?
ATE.
Yeah.
And when
Okay.
I was 7.
Okay. The 0 thinks it's so cool, right? Because the 0 is like, yeah, go ahead and try to absolute value me. I'm still 0. And then -1's like, yeah, well, I'm going to multiply you times negative. And 0's like, okay, cool. I'll still be 0. So the 0 is not changing.
Darn it.
But all of our, every output, every y value that this function had, this -1, it got it, and it made it negative. So we have -1, -1, 0, 0, and then +1, -1, which is making that reflection. Now that we've established what the charts look like, or the tables, what the graphs look like, let's start asking ourselves the trickier questions. This question is weird. It says, over what intervals is h of x positive? Okay, let's decode that for a second. Hold on. Over what intervals is h of x positive? Let's talk about what h of x means. Yes, it is talking about the whole function. Over what intervals is the function positive? But let's really decode this for a second, girls. Let's decode this for a second, because h of x is it your input or your output?
Input. No,
Output.
Output. If it's the output, is it the x or the y?
Y.
X. Or Y.
So h of x is all of our y values. So what they're asking is, over what intervals is all of the y values positive. Now, what intervals is it talking about? If we're talking about seeing if the y's positive, then what are the intervals?
H of x.
That
The
one.
pairs, the coordinates.
No. What? The x values, right? Over what intervals? So this would be the intervals that we're checking. These intervals along the x-axis, meaning like, well, from +2 to +4 on the x, and the interval, is it positive or negative? Well, it's negative, right? Yeah.
Just like, can you give Angelina a dollar instead?
I am running out of candy. Why does she feel like she needs one?
No, because she keeps answering and she never gets one.
I'm gonna do one better. I stole this from my own child, okay?
Oh, I would have done the same thing.
How could you steal?
Miss
I
like
know.
really pulling
I'm
stealing
stealing
candy from a
Hopefully they never watch this video.
Miss like literally stealing candy from me.
Stealing candy from a
You
baby.
need a child that's stealing candy.
Guys.
I am running out of candy again, but thankfully it's Halloween, so hopefully I can steal more candy from my children and replenish it. Okay,
Tomorrow's Halloween. Tomorrow's Halloween.
I'm back,
I forgot.
I'm back. Okay. So, we're looking at the intervals across our x-axis and seeing what y values will be positive.
That one.
And somebody already said it.
None. Right?
Yeah, somebody said it, I just don't remember, was it you? Somebody said it, but
All
yeah, you're right. Over what x intervals?
All
Over none of them, because it's never positive. It's either negative or it's
Negative.
0.
zero. Very good. So the answer for that is it's never positive, but thanks for asking. Then it says, over what intervals is h of x negative?
That one. Oh my
Well,
god.
No.
wait, what?
All of them except for 0.
Oh my gosh! Don't tell my kids. Stole this from them.
I want
Wow,
that.
it's
Get
like
more.
you're a real criminal.
You can only have chocolate, can't you?
I had chocolate, but I don't know.
I don't have any chocolate. Yeah.
Howard, you're, I mean,
The tower.
Wow.
Rude.
You're gonna be okay. I'm
They
not mad
look
about it.
nothing alike.
But we're equally cool, so it's okay. Take it as a compliment. Can I have your attention back to this, okay? Carmine is exactly right. It is all of them except for 0. You guys good?
It's Miss like,
Oh, the other Miss Lane?
yeah, you
Oh,
Miss Lake.
okay.
Like,
So all of them except for 0. Now there are 2 ways of writing this very interesting, fancy, up here please, up here. 2 ways of writing this. One of them is written over here on this example, and then the other one is going to be written on your homework, which is why you have to watch that video because it's very, very confusing.
You have to?
yes.
Yeah, it's gonna help you with your homework.
It gives you the tips to the home. Why would you watch it?
Okay,
For real, for real.
so the way that we would write that, what Carmine just said, is the function is negative for values. Now I'm going to insert a word here for all values. The function is negative for all values, all intervals, when x doesn't equal 0. Do you guys understand that? When x doesn't equal 0, because he said except for 0. And that means the same thing, right? So for all the values except when x equals 0, or in fancy set builder notation, it's all values if x doesn't equal 0. That's like the little caveat there. Okay, now on your homework, it's gonna say it in an even fancier and more confusing way. Wouldn't it be nice if your homework choice actually matched the answer on the example?
I don't know what it
But I talked to the company about that and they gave me a good response. They said, well, technically, both of those explanations are true and we wanna prepare them for whichever one you might see on your EOC test. So,
Dang.
on your homework, as I explained in the video for your homework, it's gonna say something very fancy like, well, it's negative for two separate continuous intervals. Two separate continuous intervals, and the homework does this while it's saying, it's like, hey, two separate continuous intervals.
Okay.
Now, how are they separate? What are they separated by?
I don't know.
The positive and negative and 0.
They're separated by 0. So this interval is a continuous interval, but it's separate from this interval, which is also continuous. Now, how can we describe in a very concise, how do we describe this interval?
Oh. Numbers. Like numbers. Oh.
If it's separated from 0.
Negative.
Yeah, negative. Or what if we had an inequality? What would we say?
Oh. -1 with the the absolute value of one number.
No.
X is smaller than 0.
Yes, x is, we would call it less than 0. And then this other separate continuous would be?
0 is less than x.
True. Just to flip it around, I'm going to say x is greater than 0. Since we're kind of identifying what the x interval is, we'll start with x, but you're totally right. If you flip it around, it would be 0 is less than x. But we'll say on your homework, it says it like this. X is greater than 0. So those are the two separate intervals. So it can be written like that, or it can be just simply written like it's negative except for 0. Yes?
So the same would apply for y. Y is less than 0 for a negative.
Well, y, did we get to the y yet? Oh yeah, no. We are saying that the y's are negative when x is less than 0. The y is negative when x is greater than 0. The y is 0 when x is 0. Are you guys with me?
Yes.
I think
Okay.
so.
All right. And Sarah, would you walk around and make sure everybody stayed on task? It looks like they pretty much are, just kind of keep an eye. I've got eyes in the back of your heads.
Wait, what?
Do you?
What's that supposed to mean?
Then your face.
Our head.
Because
What?
I've got eyes behind your heads.
What?
All right, so this diet,
I mean, my eyes aren't in your head.
this triad, I'm gonna try it with you because it's quite complicated, okay? It's quite complicated. For each function, A and B, guess what? We're not gonna do B. We only got so many minutes left in the class, so we're not doing B.
We have 11 minutes class. How many questions are there?
If I ask you a question, please feel free to answer. If I don't,
Okay.
okay? For each function, so we're just gonna focus on this one. Describe the domain, the range, and the intervals over which they are positive or negative. That's a lot to do. The interval, it's, remember how we talked about how the intervals are along the x-axis? An interval is like from here to here. So an interval could be like the interval between 2 and 3 on the x-axis. The interval could be, just as we described before, when x is higher than 0. What?
Intervals are numbers.
Intervals are, describes something between two numbers. Interval. Then, I'm trying to think of a better definition
A
for that.
distance between two objects.
A distance, yep, distance between two things, yeah.
Why is it
Okay, so,
plural if it's
imagine-
just a distance?
Because there could be more than one interval to describe.
Could be just
Oh,
one,
it's
if
kinda
there was
like a-
just one.
Well, on the previous example, remember we said that this interval, remember I said that on your homework it would be two separate continuous intervals. So this interval is from here down, and this interval is from here up. This interval is x is less than 0, because it's all of the numbers that are on the x that are less than 0. And this is all the values that are greater than 0. These are the intervals that cause the y coordinates to be negative. This 0 on the x causes the y to be 0, which isn't negative, which is why the intervals are separate. Does that make sense? Kind of. It's okay if it's not totally making sense. It's this part is the hardest concept of this entire lesson. So it's okay to let that just sink in for a little bit and watch that homework tonight, and it will help you more, okay? So back to this, we're just gonna focus on this. The graph of the function h is a reflection of this graph over the x-axis. So if they want the domain, the range, and the intervals of function h, but it doesn't give you that function, what do I have to do first? Yes.
I don't know. Can I use the bathroom? That's why I was raising my hand. Real fast. Speed fast.
Okay, but I'm also going over this fast, so you're gonna miss
Yeah.
it.
I'm gonna go faster.
So
You can watch your
basically,
videos.
Yeah.
Yeah.
what you do is you solve for this one,
Yes. And then what?
and then you basically just reverse it.
You reflect it, right? Yeah.
Put it in the mirror.
Put it in the mirror. Show it up, show it its face in the mirror and see what happens. So, before we can graph this and answer these questions, we have to graph this and then reflect it to make that. Okay, so let's graph this first. We have the function of x equals 2 times the absolute value of x. But in order to get my output, I need to have some inputs. Can you give me some input about what inputs we should use? Yeah, let's just use -1 and 0 and +1. And then let's plug things in. We have 2 times the absolute value of -1 would be what?
2.
2.
0.
2 times the absolute value of 0 would be 0. And
Wait, why? Oh, never mind.
yeah, we're just following the function. 2 times the absolute value of 1 would be 2. So here are our coordinate pairs. I'm going to go back over here and graph it. -1, +2, 0, 0, and then 1, +2. I know it's just a little baby, but we can just see how it's going to extend out and continue on forever, upwards and onwards. Okay? Oh, but that's not the function that we're actually working with. I'm gonna actually circle this in blue, and I'm going to make function h
Oh,
in blue.
I know this already.
Well, hold on.
Oh.
Do you want to reflect it?
Yeah.
Okay, come this way so you don't. Oh, it's okay. It's okay. Just
So I might be leaving.
yeah, just fix it so that you can see this also.
Is this one?
Technical difficulties.
There we go.
Okay, you can see that whole graph over here. Go ahead and reflect it.
What you do is,
Oh, you don't even need to do that over here. You just reflect it.
See how speedy that was?
ready?
That was faster than momentum.
0.
Okay.
Not really.
Okay. Now do it on the graph.
Okay, then you want to put like that.
Okay. I see what you're saying.
Yeah. So,
Mess with my graphs.
um, oh,
So for the function h, you just turn the 2 into a negative.
Yes. Very good.
the curvy line.
Yeah.
Such your lines.
I've been doing this for a while. Okay, thank you. Now this way, turn it careful. Your chair is right near the tripod. Okay, so that's very good. Now there are 2 ways to reflect this. He did it the mathematical way, which is very good. He said, well, your y values are just going to be negated, made negative, right? And then he did it mathematically. He said these are going to be your new y values. You got a -1, -2. Another way to reflect it is if you're reflecting across the x-axis, then you're just going 1, 2, and then 1, 2 down here, and then you go 1, 2, and then 1, 2 down here. Then you've got your reflection. So either way you do it, it's correct. Is it you? Well, you participated very well considering the fact that you knew you were going, so that's really good. Just be careful of the tripod when you leave, okay? All right, so does everybody see the reflection? Now, Jack, we can answer these questions. Let's start with the domain. What do you think of when you think of domain? Your x values, right? So what is the domain of, what's that? What is the domain of our blue function there?
-1, +1, 0.
That's what we did on our chart, but those are the ones that I just chose to use. Would I be able to use other x values, Vincent?
Any.
What?
Any.
Anything. Anything you want. Well, any real number. You can't use like a dinosaur. You can't use a dinosaur or like
A dinosaur.
a Jolly Rancher in your domain. It's gotta be a number. So we would simply say x is a real number. So that's the domain, nice and easy. What about the range? What do we think of when we
Our
hear
real
range?
number.
What about the
Y.
range? It's our
Yeah.
y.
2.
Okay.
Oh, sorry.
So can the range also be all real numbers?
I don't know.
That's a good one.
I was gonna say yes, but it might be no because it's only.
When you trick us like this.
Because what?
Because it's on the 0.
You're thinking of intervals, but kind of, yeah.
Arrange everything is 0 and
Everything what? You're right. I know you are. I can read what's happening in your brain.
range is 0
Yes.
and everything less than 0.
Yes. How do we write that with a fancy inequality?
0 is
No, start with y.
like y is any real number.
Oh, just you already said it.
Just an inequality. Or?
Yeah, just an inequality. Y is less than.
Yeah, y is less
or-
than or equal to 0.
Very good. I'm gonna write that in fancy set builder notation with my brackets, okay? So that's my range. Y is any real number that is less than or equal to 0. You don't have to write out real number because when you have an inequality, it does imply that all the values that you're talking about are real numbers, unless specified. So range is y is less than or equal to 0. All right, next we have the intervals over which they are positive or negative. Well, let's think of positive and negative. Well, first of all, what are we looking at? What do they mean by when I say the function, the intervals over which the function is positive or negative? Are we looking at the x's or the y's when we're trying to determine if they're positive or negative? Are we trying to determine if the x's are positive or negative, or if the y's are positive or negative? Jack, wake up. Nobody turn around.
Both.
Technically both, but the intervals is our along the x-axis, but we're trying to figure out if the function is positive or negative, okay? So, tell me which one the function will never be. Look at the blue.
Positive.
It will never be positive. Because look, it's all negative in our outputs. Our y's are all negative, except for 0. We'll get there in a second. So that means it can be positive, because it's either 0 or less, right? So we would say it can be positive. You can write it however you want. I'm just going to write the function can be positive. Now, can it be negative?
Yes.
Over what intervals? Over what intervals? So there are two ways to write this, the book's answer way or the homework's answer way, which are, unfortunately.
Why?
We would say, what are the intervals though? If we're naming the intervals,
So intervals.
When is y negative? Yeah.
When it's, when it's like, it's anything other than 0.
Exactly. We would say that, h of x is negative for values, or for all values where x doesn't equal 0, which is another way of saying except for 0, right? The fancy homework choice way of saying it is, well, technically there are 2 continuous intervals. And those 2 continuous intervals are broken up at this 0. One of the intervals is x has to be,
3, 4, 26.
somebody said x has to be negative, which is true. X has to be
Negative.
negative,
3.
inequality wise. X is negative, you're right. X is less than 0. And here's the other continuous interval, x is greater than 0. That's the other way to write it. You need to keep that in mind for your homework. I have one more thing to go over with you guys, and then we'll be done. You know the rule, if you pack up before I let you pack up, you're staying with no packs. I'm scared because I care, and I'm scared because it's rude. Don't do that. Okay. This function is going to look ugly and confusing. Don't worry, you are not responsible for figuring out why it looks like that. Let's just read about Jay's boat ride. So Jay is on a boat, okay? And he is going along this river. He is going up, and he's going between 2 counties. He's in a boat, and he's going from Monroe County to Collier County. Girls. He's going from Monroe County to Collier County on his boat. And then it shows you this very fancy function that shows the distance of the boat in miles from the county line at t hours. Do you agree that as he gets closer to that county line, it's going to take time, right? He doesn't just go from here to here in a split second or no seconds at all. It takes time. So there are 2 things that are happening. He's traveling a distance, and it's taking time. So the graph is showing that relationship between the time that's passing from here would be 0 hours, right? Then it shows on the graph, it says assume that the graph shows his entire trip. Here is the starting distance from what? The county line. Very good. How far is he from the county line? 45 miles. Very good. We see that it's up the next interval here, so 45 miles from the county line. As he's going zoom, hours are passing. Time is passing. Now it looks like it's decreasing. What's decreasing?
The time. Distance.
The distance is decreasing because he's getting closer to the county line. The distance is decreasing. What's increasing? The time. The time is increasing because the time is passing. Now, at this point, where is he?
County line.
The county line. Remember the mile markers with the groups traveling towards the waterfall? This is exactly like that. So as he's going zoom, he is traveling this distance over time, okay? So, and the distance, rise over your run, is that slope or the rate, however you want, whatever you want to call it. Now, once he hits the county line, does he stop or does he keep going? Look at the graph.
Keep going.
He keeps going. So it's not gonna go down, 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 because he's not traveling a negative distance, but he is traveling away from the county line. But we don't measure that in like negative miles. So that's why we have an absolute value function. He's traveling away from the county line now, but he's still traveling a positive distance away from it, which is why it bounces back up. As time is passing, the distance is getting greater. So we have a negative slope here as he's getting closer, and a positive slope here as he's getting further away from the county line to wherever he's going in Collier County. That's pretty much all I wanted to say about this, except that there are 2 or 3 problems on your homework that are similar to this, and they ask you questions that I promise you, well, maybe not you, but if you try them on your own, you're probably going to get them wrong, because I did. Because it's very confusing, even though when it showed me what the correct answer was, I was like, are you serious? That's the way you want me to write it? It's one of those things that will frustrate you unless you understand why they want it that way, and I tell you before you actually have to type in an answer, so make sure you watch those videos. Yes?
I got those questions.
Oh, you did get those questions wrong?
Yeah, they're
And then you fixed it. Thank you for being honest, because I looked at you and I'm like, oh, you probably won't get it wrong. You want to do an outro? Okay, why don't you close the video out for me, Bob?
Alright.
So you intro the outro.
Can I do the outro with you?
Make sure you talk about how great the lesson was and how good
Oh
your teacher
yeah.
is.
Thank you for watching this lesson, and she's a great teacher. And see you later, alligators. Ka-chow! Okay.